In this video, we're going to look at the different types of columns that are used in chromatography. And so columns are the container that holds the stationary phase when we're thinking about this as an instrument. So one of the images that has already been shown to you from the last video when we were looking at the Van Deemter equation is this one, which is an image of a packed column. So the solid black lines around the outside are just like the walls of the container. So think of this like a tube, okay? And inside the tube, we would shove in sand. Okay, so sand would be the stationary phase. The tube is just the thing that's holding it. Okay, so in a packed column, the stationary phase is solid and it's completely filled. I mean, there's some gaps between them, but I mean, it's not hollow or anything on the inside. Okay. The second type of column is an open tubular column. Oh, backtracking. This is the type of column we would see with adsorption chromatography. Okay. The open tubular column would be used for partition chromatography. And in this one, we've got our tube, but the tube walls are coated with the stationary phase, which would be a viscous liquid or like a gel, but then the center is completely hollow. So with this one, the ideal for the open tubular column is we don't see the multiple paths broadening because it's dissolved in the liquid. There's not solid particles in the way that are making a path easy or hard to get to. So we see better resolution than a packed column and higher number of theoretical plates, which is a good thing when we're looking at columns. And these are typically much longer than packed columns, and they have to be because there's not very much stationary phase. It's just around the outside. And so these are, a packed column might be the length of your pencil. Like that's how long a packed column would be. An open tubular column is like feet long. They're very long, but they wind them up. I'll show you a picture here in a second. So that's a picture of an open tubular column, but not the inside of it. That's like the outside. So it's just a long, skinny piece of copper wire that's filled with this viscous liquid, which is hollow in the middle, and then it's wrapped around this thing. When we're dealing with open tubular columns, we have to have a low concentration of chemical. Like the solute. And the pressure is going to be important. Okay. So, talking about the columns, but kind of looking at the things that can go wrong when we're making our peaks. If we have too much solute, so I just mentioned with the open tubular column, we have to have a very small amount of solute because there's not very much stationary phase. What happens is the peak gets quote unquote overloaded. Okay, so it gets overloaded, and then it could also tail. So the first image is overloading, and the second one is tailing. So in overloading, what happens is the peak kind of just falls off. And in tailing, what happens is it one end of the peak separates out. In both of these situations, the peak is no longer symmetrical. Okay, so this is a sign that your chromatography situation is not going well. Something's going on with your column, or something's going on with your settings, like you put too much chemical in it, something like that. So there we go.